Where does energy come from? The journey from uranium mining to charging your phone. The invisible power story. Right now, your phone is charging, but have you ever stopped to ask, where does that energy come from? Not just the plug, not just wires, but the source in general. In this video, we'll follow the incredible journey of electricity from a piece of uranium deep underground all the way to the battery in your pocket. It's a story of science, heat, and atom with a little explosion in the middle. Let's go. Chapter 1. Digging for atoms. Our story starts in places like Kazakhstan, Australia, and Canada, the top producers of uranium. Uranium is a heavy metal. You can find it in rocks, sand, and soil, but only special ores have enough to use for energy. Miners dig deep or use a method called in situ leaching, pumping liquid underground to dissolve uranium and bring it to surface. Uranium is then turned into a powder called yellow cake. It looks like yellow flour. This powder holds the fuel for nuclear power plants. Chapter 2. Fuel preparation. From yellow to powerful. Next, the yellow cake goes to a conversion and enrichment facility. Why? Because natural uranium isn't strong enough to power a reactor. So scientists use machines to enrich it, increasing the part called U-235, the isotope that splits to make energy. Then it's turned into small ceramic pellets about the size of pencil eraser. These pellets are packed into long fuel rods, which are loaded into the core of nuclear reactor. Now we're ready to unleash some serious power. Chapter 3. The reactor. Splitting atoms to heat water. Inside the nuclear reactor, those tiny pellets do something incredible. They split atoms. The process is called fission. When a uranium atom splits, it releases heat and more neutrons, which split more atoms. A chain reaction. But don't worry, it's 100% controlled. Modern reactors are built with cooling systems, control rods, and 6 safety walls. The heat from fission turns water into steam, just like a kettle. This steam goes to a turbine. It spins and makes electricity. From atoms to steam. From steam to power. Chapter 4. The grid. High voltage travelers. Now we have electricity, but it's still at the power plant. How does it get to your home? First, the electricity goes through transformers, which increase the voltage so it can travel long distances without losing energy. Then it moves through high voltage power lines across mountains, rivers, and cities. These lines carry the power to substations where voltage is reduced for safe home use. From uranium under the ground to wires above our heads. Chapter 5. Home delivery. The last stop. By now, the electricity has arrived in your neighborhood. It flows through underground cables into homes, schools, shops, and your bedroom. When you plug in your iPhone charger, a circuit completes. And just like that, the energy that started in a nuclear reactor charges your phone at home. Chapter 6. The future of this journey. This journey might sound high-tech, but it's just the beginning. New nuclear designs, like small modular reactors called SMRs, are being built. They're cheaper, safer, and can power small towns or even factories. And what about fusion? The same process that powers the sun? Companies like General Fusion and ITER are working hard to make fusion energy real. In the future, your phone might charge from a power plant that uses zero waste, zero carbon, and pure plasma energy, or simply have an isotope battery that doesn't not require any charge at all. The journey is still being written. So the next time you plug in your phone, remember, That simple charge took a trip through minds, machines, atoms, and wires. Energy doesn't just appear. It travels, it transforms, it tells a story. If you like this energy journey, hit that subscribe button and power up your curiosity.